Many processes can be well approximated by the normal distribution, such as SAT scores and the heights of U.S. adult males, for that matter, adult females as well. While using a normal model can be extremely convenient and helpful, especially when you're doing probabilities using the normal probability calculator, it is important to remember that normality is always an approximation. So, testing the appropriateness of the normal assumption is a key step in many analyses. Visually, there are two methods for checking the assumption of normality, which can be implemented and interpreted quickly. The first, which we've already seen, is a simple histogram with the best fitting normal curve overlaid on the plot. And you see that on the left here. The sample mean and standard deviation are used as the parameters for the best fitting normal curve. The closer the curve fits the histogram, the more reasonable the normal model assumption. Another common method for assessing normality is given by the normal probability plot, which you see on the right. The closer the points are to a perfect straight line, the more confident that we can be that the data follow the normal model. Now, the way these graphs are made, on one side, in this case the vertical axis, are just your data points. Or the y values, the vertical values are the data points. The other side, in this case the horizontal axis, is theoretically where those values would be if you were a perfect normal distribution. So if your data fits a normal distribution, it's going to match up with the theoretical normal distribution on the x-axis, and everything will fit along that diagonal line. If it doesn't fit normality, then you're going to see some kind of curve or bend. So, nearly normal data will have a histogram and a normal probability plot that looks something like this, where the histogram will generally be unimodal symmetric. Real world, don't expect it to be perfect. But if it's generally unimodal symmetric, then we'll say normality is good. For the probability plot, we're looking for your dots to fall along a line. So in this case, this would be an example of something that's that definitely meets the normality condition. On the other hand, histograms are distributions that are not normal, are not unimodal symmetric. There'll be a definite bend. So in this case, there are two peaks. So this is really bimodal, not unimodal. And as a consequence, what happens is that my probability plot has an S shape to it. So reading normal probability plots takes a little practice. Even samples from true normal distributions are never going to be perfect, especially if you have smaller samples. Indeed, samples from true normal distributions will typically have points that meander above and below that will generally follow the line. As you take larger and larger samples, it looks better and better, but for smaller samples, it'll generally snake, meander above and below. So, just for some reference, here are three sets of 40, 100, and 400 from the same distribution. And you can see all these came from normal distribution, but you notice that this far left one is a sample of 40. It doesn't really fit great. I mean, I guess you could call it unimodal, sort of. Probability plot, you can see that it's below the line, above the line, below, above is kind of snaking above and below the line, but generally following it. There isn't any real noticeable curve away from the line. 100 is better. A bit straighter, but again, not absolutely perfect, but real world, never going to be absolutely perfect. 400, even better. It looks fairly straight, not a whole lot of meandering here or anywhere. Okay, so some examples. This one here, if you look at the histogram, you see that it's definitely skewed right. And the probability plot, you see a giant bend. So this is not normal. The distribution is heavily skewed right. This one, looking at the probability plot, you can see that sort of that snaking. It's not really bending away. It's sticking towards the line, but going above and below. This one, I see the sample sizes are pretty small, so this is pretty much what you expect from a small sample size. So this one, the distribution is approximately normal. This one, also, I mean, there's one big bar in the middle, unimodal, more or less symmetric, probability plot above and below. This also fits the normal distribution. For this one, there are two definite peaks, and this does not look like random chance. This graph is bimodal. And from the graph, we see the S-curve. So not normal, distribution is bimodal. So for some reference, here's some graphs and the probability plots to go with them. So for symmetric unimodal graphs, the nicest kind, the probability plots will look like a straight line. If it's right skewed, like you see in this histogram, the probability plot will have a noticeable bend upward. Left skewed would be that the probability plots will flatten out. It'll start off fairly vertical, then kind of flatten out as you move to the right. Likewise, that's left skewed, a long left tail. And bimodal will have two peaks. You'll see this little S curve in your graph.